Okay, we're going to do a couple of example problems here on gravity. So the first one, find the acceleration due to gravity of the sun at the distance of the Earth's orbit. That's number one. And then we're going to look at a geosynchronous satellite. So let's do first ones first. Okay, so we want to find the acceleration due to gravity, right, at Earth's orbit. Okay, so we have to draw the sun. It's a fiery ball, and we got the Earth some distance very far away. We'll call that R. And the free body diagram actually is just one force acting on the Earth, force of gravity, between, so it's the force of the sun on the Earth. And of course, the sun has equal and opposite force on it. So things that we are given, even though it's not explicitly stated, right? We have just a lot of constants here that we're going to need, right? So G is 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. We are going to need the mass of the sun. Mass of the sun is 2 times 10 to the 30 kilograms. And we will need this distance as well. This distance, for those of you who are going to be going on to do some astronomy, this is known as 1 astronomical unit, 1 AU. So that separation is 1.5 times 10 to the 11 meters. Okay, so if we look at the forces acting on the Earth, right, we can sum the forces in the radial direction. That'll produce some acceleration in the radial direction. And that's what we want to find. That's really the acceleration of gravity. Okay, so the force that's acting on the Earth is the force of gravity. So G, mass of the sun, mass of the Earth, divided by that radius squared, is going to produce the acceleration at the Earth. So mass of the Earth times the acceleration. And that's what we're solving for. We have mass of the Earth on both sides. We can cancel that out. So we get that the acceleration, gravity at the Earth's orbit is gm sun over r squared. So let's plug in 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. Uh-oh, gonna run out of room. We'll just do 2 times 10 to the 30 kilograms. And then we divide by 1.5 times 10 to the 11 meters squared. And if we plug in those numbers, we should get that the acceleration due to gravity is 0.00593 meters per second squared. Or we can put that in scientific notation, 5.93123 times 10 to the minus 3 meters per second squared. Okay, that's the first one.